Hey everybody, Mr. Murray here. I'm Mr. Murray's Mathland, and today we're taking a look at solving basic trig equations. So we're basically just trying to go backwards and, looking at this first equation, sine of theta equals root 3 over 2. You're trying to find the angle or angles, the value of theta, that would make this a true statement. The sine of what angle equals root 3 over 2. Just notice the way the directions are phrased. This one in particular says solve the equation over the intervals 0 to 2 pi and over 0 degrees to 360 degrees. So we're going to give our answer or answers in radians and degrees just for a little practice. But often the problem might just say one versus the other. And also notice the bracket around 0, that's inclusive of 0, and the parenthesis around 2 pi and 0 and 360 respectively mean, you would give 0 as an answer as opposed to 360 degrees, since they are coterminal, they're at the same spot on the circle. So if it comes down to that, you give 0 instead of 2 pi, or 0 instead of 360. Okay, so let's get into this here. Now, when you look at this equation, you might just know right off the top of your head, depending on how well you know your unit circle and your triangles and your values, when does sine equal root 3 over 2? If you're still trying to find a method to help you come up with that info in a fairly quick way, here's the old chart again. Just can't hurt to see it again. 30, 45, 60 in that ascending order. And in radians, that's pi over 6, pi over 4, pi over 3. Sine, cosine, tangent in that order. And remember, these values come pretty quickly. There's a nice little pattern to them. Sine and cosine are all over 2, over 2, over 2, over 2, over 2. The numerators are root 1, root 2, root 3 in that order, and backwards for cosine, root 1, root 2, root 3. Divide your sine by cosine to get tangent. So just look at those numerators. 1 divided by root 3 gives you root 3 over 3. Root 2 divided by root 2 is 1. Root 3 divided by 1 is root 3. Okay, so this gives us a good starting point here. Now the thing to consider here is that you're saying when is sine equal to positive root 3 over 2? You got to remember your 4 quadrants, that sine is positive in quadrants 1 and 2. Everything's positive in quadrant 1, and sine is positive in quadrant 2. So we're going to have two answers for this. We're thinking of the same things, but kind of in reverse. What's our reference angle and what quadrant or quadrants? So when is sine equal to root 3 over 2? That's at 60 degrees or pi over 3. But that, of course, is just the reference angle. That's the quadrant 1 answer. So quadrant 1 and quadrant 2. We know there are two answers for sine being positive. And our quadrant 1 answer is pi over 3, or in degrees, 60 degrees. The quadrant 2, you can think of it one of two ways. If you really know your unit circle values very well, you know that this angle in quadrant 2 that has a reference angle of pi over 3, that's like the quadrant 2 version of pi over 3. That's 2 pi over 3. Always one less than the denominator for those benchmark angles in quadrant 2. And in degrees, that would be 120 degrees. Or you can always think of if you like the degrees, you can think of that first and remember that, hey, there's our reference angle of 60 degrees. So the angle we're really looking for is 120 degrees. And then you could convert that to radians if you like. So you can start with either one and go the other way with it. So there's our two answers expressed in radians and degrees. Very nice. So let's try just a couple more examples just so you kind of get the feel of it. All right. So let's see here. There's our chart. I brought it back here. Okay, so this one is saying, when is tangent equal to -1? Okay, so I'm focusing on the 1, first of all. That just jumps out at me. When is tangent equal to 1? Tangent is equal to 1 with a reference angle of 45 degrees, or pi over 4 in radians. So when is it -1? So again, think about your quadrants here. When is tangent negative? Well, it's positive in quadrant 1 and 3. That's what the T, remember, represents, is what's positive in that quadrant. So it's negative in quadrant 2 and 4. Okay, so our answers had better be something in quadrant 2 and quadrant 4. And drawing these little diagrams here is certainly not necessary if you can just spit out the answers. Just a way to help you visualize quadrant 2, quadrant 4. So again, the reference angle is pi over 4, or 45 degrees. And that's this angle. So what is that angle in standard form that's going to put us there? And you know, if you're a radian person, you kind of just know that, hey, in quadrant 2, the pi over 4 that's in quadrant 2 is 3 pi over 4, one less than that denominator. And in degrees, that's 180 minus 45, right? That's 45 degrees there between the x-axis, so 180 minus 45 is 135. Or just convert your 3 pi over 4 to degrees, however you like to come up with it. And in quadrant 4, again, there's your 45 degrees or your pi over 4. You're looking for this angle though. So if you know your quadrant 4 radian value, the radian version of pi over 4 in quadrant 4 is double the denominator minus 1, and that is 7 pi over 4. You know, 4 times 2 is 8, minus 1 is 7. And the degree version, you can either convert that or just do 360 minus that 45. 315 degrees. Yeah, and when you do that double the denominator minus 1 little pattern trick, I mean, all you're really doing is subtracting pi over 4 from the full circle of 2 pi to get the remaining portion, the remaining angle. So there we go. There's another example. 2 answers in radians and degrees. Okay, one more just to see what we think here. Okay, we'll bring the chart back here. Love that chart. Very helpful. And now we're saying, when is cosine equal to -1? So again, I might focus on the 1 at first, but looking at my chart, cosine is never 1 at any of the benchmark angles. So is this a no solution kind of situation? And no, you just got to remember that there are times when sine and cosine are 1 or -1 or 0, and that would happen at one of the quadrantal angles. So think of the whole circle and think of the coordinates at each quadrantal angle, right? It's the unit circle, the radius is 1, so that's 1, 0. That's 0, 1, you know, 1 unit straight up. 1 unit straight to the left is -1, 0. 1 unit straight down is 0, -1. And when you say cosine, we're saying, when is cosine -1 on this circle? Remember that cosine is the x-coordinate and sine is the y-coordinate, right? X before y, c before s. And so when is the x-coordinate -1? That is at one location only, and that is right here. And so that angle is 180 degrees in degrees, or pi in radians. And that's it. So that just goes to show that not every trig equation is going to have 2 solutions when you're talking about this, you know, over 0 to 2 pi interval. Often it will if you're in the quadrants, but if you're a quadrantal angle, you might only have 1 answer. So there we go. There's 3 different examples to hopefully give you an idea of what you're looking for here. If you have any questions, just feel free to ask, as always. Take it easy, kids.